Hello. Oh, I guess it helps if I do that, huh? Welcome everybody to the very first episode of Tech Talk Tuesdays. So glad you're here. This is going to be on the first Tuesday of every month. We're going to let the stream kind of build up a little bit here for just a couple of minutes while we get things rolling. I'm going to post a couple of things. Welcome everybody, and we'll get this rolling here in just a second. So while we're doing that, I'm just going to type in the chat here, hello. Please let us know your questions. So that's what we're going to be talking about today. If you didn't see the post that just popped up over there in the feed, we're going to be talking all about 3D printing today. And I know for a lot of people this is kind of a weird place to start, but it's actually a really great place to start. Because I know I've talked personally with so many investigators that want to build their gear or modify their gear a little bit for use case scenarios where they get in and they go, you know, I love this thing, but I just wish it had a handle here or something I can hold on to it or better feed or something like that. So this is a great way to, one, start answering some of those questions and give you some ideas, and two, introduce this technology because we're going to use it down the road on building some gear with you guys over the series of this broadcast. So starting today, we're going to talk a little bit about 3D printing. I know a lot of people don't really know what 3D printing is, and so we're going to talk a little bit about what it even is and how it works. In fact, I'm going to go ahead and turn on the view that's going to show you the print I got running right now. So here is a print that I have running, and so if you're looking at this, well, I guess I got to point this way. If you're looking at this, you can see the nozzle of my 3D printer right now, just kind of going to town printing this printout. And this is actually not gear related right now. This is actually a print that I am printing that is a race car frame for a friend of mine. So we're printing out this race car frame for an RC car so that we can fit it right. So this is actually just a prototype. So I'm gonna give everybody a little bit of time to start getting in and getting on. So welcome, I do welcome you. Please make sure you hit that subscribe button today. And can't wait to see some of the questions everybody has. But we are live with Tech Talk Tuesday, and I can't wait to really get this going with you guys. So what you're watching right now is a 3D print I have on my 3D printer printing away. It's been printing for about 20 hours, so almost a whole day, which seems like a lot, and it is, but when it goes to prototyping, it's actually pretty fast, and that's kind of what we're going to get to. In just a little bit, I'm going to show you some cases I've made for gear for the Ghost Geeks and kind of give you a peek at what we're building and how we build it. And again, that's the whole process here. We want to make building your own gear a little more accessible, or at least if you don't build your own gear, at least you'll have a better understanding of how the gear works. So we'll go through some electronic components further down the line. We'll even talk about computer coding, because some of the things you do, you have to put in a microcontroller to control it. And so that's something that we're going to do. If you've never worked with an Arduino or a Raspberry Pi, we'll get to that here sooner or later, and we'll show you how easy it really is to code these things, because trust me, when you start building your own gear, troubleshooting it in the field becomes a lot easier because you know exactly what's going on, you know exactly how it's supposed to respond, and it also gives you the edge because you know when something is malfunctioning versus actually getting real responses, and that's a big deal. So I'm going to give everybody a little more time here. We are getting some of this shared out there and getting it posted, just so everybody remembers to come on in and do this. So we're going to share this to a group. Let's see. Oops, I think I was supposed to click that button. Woo. That's going to be fun. Okay, so share. So I'm glad you guys are with us. If you just give me a minute, I'm trying to get the stream kind of rolling with some posts on us going live. So make sure you bring in your questions and you jump on over here and just let us know what you would like to talk about. If you've been wanting to get into 3D printing, but you have some questions on, cost, setup, that kind of stuff, let's talk about that as well. There's so much we can cover in 3D printing. It's hard to just go, let's do this one quick episode on 3D printing, right? So let's start there. If you are into 3D printing and you're new to it and you're not sure what's going on or how to do things, let's get some of those questions rolling in. Make sure you put them in the comments. If you are a 3D printing veteran, then please by all means jump in and give us some of your best tips on 3D printers and how to really get your printer ready to go and really putting out great layers. Like you can see mine, I've got some really fine layers going on here. I do like to print fine just because it helps take away that layering effect. And for me, it prints a better product at the end of it. So we want to welcome everybody. Welcome to the Ghost Geeks Tech Talk Tuesday. We're going to get started now. So what we're doing today is we are going to be talking about 3D printing. And 3D printing is basically an additive process. So it's a printer that takes a filament and it melts it through a nozzle and lays it out, just like an old plotter would do with a pen drawing lines on the paper, except this draws lines of plastic and it goes over itself over and over and over again to build that layer up to create a 3D object. It's 3D printing. Now, what happens with this is you don't just have something, you have to design it. And so there's a bunch of different ways that you can go in and design whatever it is that you're trying to do. And so for that, I'm actually going to jump over and let's see, we'll go to screen share on Fusion. So what I'm looking at right now is Fusion 3D, and there is a free version of this and a commercial version of this. So one of the things that we're going to do is just kind of look at this real quick. This is an EM pump that we've done, or actually this is an EMF pump. People call them EM pumps, but that is actually not the correct term. We can talk about that if you want to, but it's technically not the right term. So this is an EM field generator, and you can see here, it really does a great job modeling things and really getting it however you want it done. And it's not a hard software to use. You start with sketches, so draw it out, measure it out, you put it into the software, and then you basically extrude it up and down. This software is really, really easy to learn. We're going to go into a deeper dive of this later in another episode, but there are tons of videos out there where you can actually go in and look at different demos of this. There's a lot to learn here because not only does it do 3D extrusion like this software also does circuit board design. And that's really, really crucial because then you can bring your circuit boards into this. As you can see, I have holes drilled in this that it's going to print like that. It really brings it into it so that you can make sure everything fits beforehand. You know as soon as you print it, it's going to fit. So this is actually a case we designed. In fact, let me grab that case. So this is actually the case right here. And so if we're looking at this case, let me jump back over to the main screen here. So if you look at this case, here it is, right here. So you can see it's pretty cool. And it didn't take long to design this. I think it took me 30 minutes to kind of come up with how I wanted it to look. Made sure took some measurements to know exactly how it's going to fit. I brought the motor and the battery bank in there so I could figure out that. You know, it's a two-part. It's got a locking lip, so once it gets onto each other there, it's going to just seat itself real good and click, and now it becomes one unit. So there it is. And then I'll show you one of the other prototypes that we were working with. This was pretty cool. So this was one of the prototypes that we were working with. So you can see this went on like this. If I can get the wiring back in there. And I'll show you what happened with this one. Assuming I can get the wires back in right. Here we go. Gotta love it. So getting the wires back in there, getting it sealed back down. This one might not sit back on because I've got... So this one isn't going to sit flat anymore because I've kind of messed with it. So what happened with this one is the design on the inside actually had posts. I don't know if you can see that. Those posts right there. And I made threaded posts for it to automatically align up to the holes down here so that when you got to the bottom of it and you screwed your screws in, it would just automatically go in and lash this together. Well, it turns out that the tension required actually snapped those off. So you can see that. So design 1, fail, which is fine, which is what led to design 2. I turned it on. Okay. So what led to design 2 is we actually integrated into the sides of the case all the way down, and instead of being threaded, I actually put in just some holes here so that I could melt in some pre-threaded brass machine screw heads. So now this will screw into that. We can use a much shorter screw. It's not going to torque on it, and even if it does torque on it, it's not going to matter because that is part of the body, and it's no longer able to just turn on its own and shear off. Plus, the point at which the torque is happening is much closer to the surface rather than putting the anchor point so far away from that. So that was a big upgrade. Another thing we did is we actually see there, we can see through that now because we took the prototypes out on in an investigation, and since I didn't have a light on them, I couldn't see these things in the dark at all. I mean, black case, black hull, good luck, you're going to step on it, trip, and fall, which I stepped on it a couple of times. So what I did is I went ahead and made this see-through, and that was really easy to do so that when I could put an LED in here, and since the LED will be in there, it'll glow, and it'll give me a little bit of light to see this in the dark without ruining the dark aspect of where we are investigating. So we got this one coming up, getting this ready, and it's a pretty cool process. Like I said, you're watching the screen here on a print that's actually getting printed, so you can see now it's layering up for the trunk, I think, or the hood of the car that's getting printed. So it's really cool. If you have any questions, please post them out there in the comments. I want to answer any questions you guys might have because this is a really, really cool technology for you to use. Like I said, here's the exact case scenario on it, is we're building cases for our equipment for in the field. And eventually, you guys, we'll give you the files. You can make these yourselves. But then we're going to start talking about things like how to do the electronic boards. Now this being an EM pump, this is super simple. So what I've done here is inside this case is actually 2 very strong magnets, and they're cased in here with a locking head, which then locks onto the motor. And it's just a really simple circuit onto a switch. But what's really great is when you turn it on, that spins, right? Well, the spinning of those 2 magnets creates an electrical current, an electrical field, and that field goes outward. And so if I were to grab a K2 meter, you could see it on there. So let me grab a K2 meter real quick. So here we go. So here we got K2 meter. And actually, let's start it with it off, right? So K2 meter, nothing, right? It's 1 bar. So, but if I turn this on, there they are. So this thing just sits there and cranks out that magnetic field. The theory is that the magnetic field allows a way for energy to escape because it's exciting the field around it, and it basically ionizes the atmosphere and allows spirits to use energy. And so that's kind of the theory is that it gives it an energy source. It's basically a battery with a big power source on it. So think of it as like wireless charging for a spirit, right? So that is the basics right there. I mean, you can't get any more simple of a circuit than battery positive, negative line, to a switch. Super, super easy. And we will be going into that more detail. But let's look at the actual 3D printer now. Let's switch over to the 3D printer. You can see my bench test over here. So let's look here. So hey everybody, here we are. Hello. So what we're looking at right now is this is actually the 3D printer, and I'm not going to sit here and lean over the desk. I'm going to let you just look at the 3D printer for now. So this is an enclosed 3D printer. It's got the shelves here. It's got a touch screen interface here, the lid on it. You know what? Let's get a little closer, huh? So we can do this though. So let's look inside. So right now we're looking inside. You can see the 3D printer kind of going at it. I'll look from this side. You can see the mechanism going. And so this prints from the top down. So the print actually starts up here, and then that bed that you can see right there pulls itself down as it goes. The filament's over here on the side. It gets fed up through a nozzle and goes up here. And you can see it just gets it hot and melts it and lays it down. So you can see in there. So you can see it printing right there. So that's what's going on with that. It's actually a relatively simple technology. It's nothing crazy hard. It does take a minute to, get everything configured and get it running good. So it takes a little bit of setup time, but the setup was really easy, especially on this. This is an Ender 6 from Cruelty. It was, right out of the box, it was mostly assembled. I had to put the 4 stands on and then bolt the motors to it. It took me, an hour. In fact, there's a video on the channel of me assembling it. So it did not take me a very long time to assemble the 3D printer. The cost of it, I want to say it was just over $500. And then I had to buy the topper separately, which was like another $120. And I've done some upgrades to it. I took the plastic little snake they did, and I put in a chain drag, cable drag, so that it was a little more organized. I added this camera feed that you're seeing right here, this one right here. I added that and actually printed a bracket for it to hold the endoscopy camera so that I could watch that. I can also view that remotely, so that's pretty cool. I can monitor my prints wherever they go. But I see we have some people jumping in, so please ask some questions. So relatively cheap to get into it. A lot of people are like, hey, $500, that's not really that cheap, but 3D printers can go up to thousands and thousands of dollars. And for the quality that this thing has put out so far, I'm really impressed with it. Once I got it dialed in, it's almost set it and forget it. Basically, I designed the files and I'm dragging and dropping them, running tests on them, really getting some good control over what I need to do with it. And so the technology is rather easy to use, and I think it's accessible to everyone if you're just a little bit computer savvy. And you don't even have to be major computer savvy, because you can go to places like Thingiverse. If you've never been to Thingiverse, they've got files already built there that people share. So we go there, you share them, you could download them and print them right away. There's no tinkering with it unless you need to. So you could just go download the file, put it on over, and just start printing that sucker. So that's kind of what's going on. We're watching this print now, and like I said, it's 20-something hours in. It's about 3/4 of the way done printing. And this is actually a race car cover for an RC car. So what you're seeing it print now is actually supports so it can get to the roof and not have the roof fall in, because that's a long way to try to span hot plastic and not have it droop. So it's building supports up as it builds the car inward. It's building supports up to support that roof structure. But like I said, we're using it to build our cases. And what's really great is you can really, customize, personalize your case. So like for example, in this case, I got the name of what it is. I got our title right here. I've already put on and offs with switches. So, if you build your own stuff, you can put your name on it. That way it's never a guess that, hey, that's mine. No, that's yours. Maybe that's mine. You don't have to worry about, peel off labels. I hated that. Our little sticky labels always fall off. And they're just like, oh my God. And everybody looks like a square black box. So, I didn't make this one square. Really easy to tell it's not yours. It's not square. Then it's totally customizable. You like the color green? Well, you can make it glow green. You like the color red? Put a red LED in it. No big deal. So lots of fun ways to customize your gear as well. And then, if you're creative and you're kind of like me and you like to tinker with stuff, it's a great way to, really kind of test and experiment with the theories behind equipment. So you can go out there, like I'm working on a data logger right now, which is basically, it's just a box that records data from everywhere. Shadow density, light intensity, luminosity, humidity, relative pressure, barometric pressure, all that stuff, temperature. So it's going to record all that. And then that way, when we go back to it, because we always set it near a camera, you put it into a graphical scene, and you can say, hey, I noticed we had something weird on this video camera, and it just so happens that every time we see this anomaly, the temperature drops or the humidity drops, or it really was a shadow. We had a luminosity change in the hallway. So now we're starting to pull in more data to quantify, rather than making our field so qualitative, stories of what's going on. Now we're getting some quantitative data. And I think that is an important aspect that our field really needs, is the quantitative data to back up what's going on. So maybe we can start seeing some relationship patterns on what's going on in our environment that might give us some insights on what is actually occurring in what we're calling paranormal. So that is really, really important. And if you're not recording any kind of data with your paranormal equipment, then all it comes down to is, well, this one time we had this experience, and this one time we had this experience. Rather than saying, well, over the last year, we've noticed that every time we've had this experience, we've also correlated temperature changes of plus or minus 6 degrees. Relative humidity is always minus 6%. You're now really starting to put quantitative data behind it, and we can even take that data now and refine our equipment, which is why I love this so much. I love building the gear. It's really one of the greatest things that I like to do. If you have questions, please put them in the comments. I'd love to hear your questions on 3D printing, and especially like what is some of the first things you'd like us to build live. I know we're going to build a REM pod. We're going to turn, hold on, you're going to love this. We're going to turn this big old guy into a REM pod. That's going to be a fun episode. We're going to turn this teddy bear into a little guy that likes to talk and do things. There's another product that's kind of like it, but we're going to add more to this guy. He's going to also log all the data that's coming in as well as record. So this is going to be a fun project we're going to build together. We'll go over the computer coding for it. We're going to go over the circuit board make for it, the logic board. We're going to do that together. So it's going to be one of those things that if you want to do this, we're going to start posting parts lists. That way, as we get to those episodes, if you have your parts list, you'll be able to build along with us, which should be a lot of fun. If you have problems getting parts lists, we're going to look for places we can resource these for you guys. That way it's easy to find. We'll start posting in the links. Hey, if you want to build along with this episode, then here's the kit on Amazon or whatever. Go buy it. And then when you get your kit and we have our episode, we're all going to build it along together, which is going to be great. So 3D printing is really a, it's quite fun. I know I've probably said that a couple of times, but watching your ideas come to life in form and shape is pretty cool. Do I still have my little test bunny? I don't know what I do with my test bunny. I must have knocked him off the shelf. Oh, there he is. When you take a little file and you take him and you do this and you turn it into something tangible, it's no longer a sketch. You have a tangible thing that you can do and you can make it your own. That is quite a fun thing. So we're going to stay going on here just a little longer as we watch this print build up. There's a number of let's talk about cost too. So we were talking about the printer itself costing about $500, and some of the accessories, couple of $100, $100, $200 in accessories that I put on it. Filament costs are kind of all over the place depending on what filament you want, because they make tons. They make glow-in-the-dark filaments, black, reds, metallics. You can buy nylons. You can buy carbon fiber reinforced. So there's a lot of options out there as far as filament is concerned. I'm printing right now in just a PLA Plus from Duramics, I think is who is it from. So this filament costs, I think it was $22, $23 on Amazon. Shipping was free, and it's a kilogram. And this race car that I'm building, which is about as big as I can print this way, definitely not this way. I can go real big this way. But as far as I can print on my X and Y, it's about as big across the bed. I actually had to turn the car catty-cornered so I could get it all on the bed. Cost on this is going to cost me like $3 or $4, which isn't bad when you talk about prototyping stuff that you want to build. So it sure beats, and even if it comes down to you print your own stuff this way and you're not mass producing it, it still comes out cheaper than you going to, you know, Home Depot or buying on Amazon the little boxes. Let me show you these boxes right here. So, you know, who doesn't see these? You know, everybody's probably bought some kind of equipment that was in a box like this, right? Just a standard square box. Well, that's great and all, but now you got to drill all the holes in it. And it doesn't always have a good way to, like, if you look in here, if your PCB board, your control board, your circuit board, whatever, doesn't fit those posts, what do? You know, you got to deal with that. So it's really great when you can go, I know exactly where the parts are going to need to fit. You put your own posts in there, and now you can, you know, align everything exactly how it needs to go. There's no guesswork. You can, like I said, you can go ahead and put your own holes in it. Put your own holes in it for your switches. You don't have to cut these out. Square cuts, those are hard. You get those corners nice and clean, but if you look at mine, I mean, that's clean on the inside. That's super smooth. Everything's going to be a nice tight fit. It just really makes building your equipment a lot easier. Do we have any questions out there? Anybody watching that's got some questions, just type them in the chat window. Let me switch over here. Sure, I got it. Yeah, we got the live chat going. So somebody just asked me, did that print finish yet? Not yet. So yeah, so we're sitting here watching a print go. This actually is a print fulfill. It's almost done. It's getting to the top now, so it's getting pretty close. But 3D printing is a pretty cool process. Like I said, learning Fusion. I'll show this again. Learning Fusion isn't hard. It actually is really, really easy. If I take this back, just kind of showing you. So if we're looking at this, so basically you just kind of draw how you want it to look. You know, you get all your line work together, you use some calipers, take some measurements, and you use those measurements to draw all your stuff. And then you just really extrude it. And it's as simple as, you know, clicking, I need this to be thicker, and hit extrude, and it'll make it bigger. You need to put a hole in something, you need to revolve something, make it an arc, you need to join some things. So again, we're going to go into Fusion in more detail, and like I said, if you can't wait for the next episode to talk more about the design stuff, there is tons of video out on YouTube that you can look. In fact, Autodesk, who is the maker of this, Autodesk Fusion 360, they have their own channel that is nothing but support and tips and tricks and how-tos on Autodesk Fusion. So there is a plethora of resources out there for you to use to go and look at how to do this. Super, super simple. It's not like old school AutoCAD. AutoCAD, you know, I grew up with that, so it was easy for me to kind of transition into this. But for a newbie that's never done this, this is actually really simple to learn. It's not hard. If you can draw some lines, or even if you know exactly what it's supposed to be dimensionally, you can draw by dimensions. You know, I need a square that's this big and this big, and I need a circle that's this big. So it really does make designing and mocking up your products really easy. So that's kind of just the gist of it. It's super easy. So again, the 3D printer itself, really neat technology. It's extruding out plastic, building them up by layers to make it. There's some nuances to that. So you know, if we get some questions on it, or if you have questions, please feel free to message us. That's great. Hit that like button and hit that subscribe button while we're talking about it. But you know, it's a fun way to, again, really just kind of stretch your legs in the world of creativity to help build some equipment, because equipment's not cheap by any means, and I understand why. I mean, it takes a lot of work to prototype and build, and you go through a bunch of iterations before you finally come up with the finished product, and you could spend $2,000 or $3,000 just prototyping a new piece of equipment to get it to work and operate consistently and function correctly. So I understand the costs involved there and why it's so expensive. But if you're good with electronics and you don't mind getting your hands dirty, doing this is a great way to really just get to know your equipment better. Because I know a lot of people use equipment out in the field, and it's like, all right, it's a REM pod. Okay, what does the REM pod do? Well, it detects things around it. Great, how? Once you get to that question, everybody just kind of scratches their head. They don't know how it actually works. What is actually being detected? And that's something we'll talk about later on down the line too, and probably come up in Friday Night Frights even. So just something to think about there. I haven't seen any more questions come in, and we had a couple of questions about costs. I hope I answered those pretty good. It doesn't take anything extra. You're not having to rewire your house for electricity. It just works on a regular plug-in socket. It's so simple. It's kind of overly easy. You kind of think about it going, I must be doing something wrong. No, you're thinking too hard. It's that simple. So again, we're watching a print get ready to finish printing here, and just start working on some new ideas. So if you guys have a device that you would like to see us build on the next Tech Talk Tuesday, please leave that down in the comments. Even go over to Texas Ghost Geeks on Facebook. Pop it on Facebook. Send us a message. Let us know what you'd like to see, because we want to build the stuff that you guys want to use. So if you want to see us build a REM pod, we'll build a REM pod. We're working on an Ovilus type device, so if you've got the need for one of those, we'll talk about that. That one takes a lot of computer code though, and it takes a little uploading into software databases. So yeah. Any other questions out there? Well, it looks like our questions have paused out, so I haven't gotten any more messages about questions. So with that being said, that might do it. I'm trying to think of what else we can cover. It's fun to just watch the printer print too. It's kind of mesmerizing, which we might just switch over and let it run live and let you guys watch it for a little bit. But this print is almost done. I am printing at, I think I'm printing at 60 millimeters per second, which isn't as fast as this printer can go. This printer can do almost 3 times as fast as what we're watching, or over 3 times as fast. It can do 200 millimeters per second, but I don't like pushing it that fast because, one, it gets louder, and you introduce the opportunity for more errors when you do that. It can get going so fast that you might get some overshift on your axis that it goes a little too far before it snaps back. So there's all sorts of ways that you can make your printer not happy with you. So I just tend to keep it nice and steady. I set it slow for the first couple of layers so I get good bed adhesion. Then I crank it up and let it go a little faster. I might try doing a rapid print on here and seeing how fast it can do it. But there's no need. Most everything I do I can set and forget overnight, and it'll be finished by the next day, or even multiple versions of it. Because like when I do these cases right here, when I do these, I can set 5 of these across it, and it'll print 5 sets overnight, which is a great way to get that done. So, all right. Well, if that's all we got, that's all I got. See if we can't So it's really cool watching that nozzle go. I'll switch back to that in a second, but if you watch the end of that nozzle real close, you'll notice the actual plastic coming out of it. It's making just a tiny little layer and it's just blobbing it down as it goes, drawing it. It's kind of satisfying to watch that. So let me go back to that big screen here real quick. So yeah, it's a pretty neat process to watch. I leave a camera going like this live when I print, so that I can watch on my phone just to monitor my print status. And so it's pretty neat to do that. There's all sorts of upgrades and modifications. If you go to Thingiverse, you'll find everything you could ever dream of. In fact, I used my 3D printer to print my audio controller, my audio interface under desk mount, which I've posted on our Instagram. So if you've never seen that, go over there and check that out. There's just lots and lots of uses for a 3D printer, even outside the scope of the ghost hunting world. I got a couple of questions here. Said, what's the spiderweb looking stuff on the print nozzle? That's actually blow off. So as the nozzle hops from one far place to another, the plastic, sometimes it just leaks out just enough to make this micro hair like cotton candy, because there's actually a fan that's blowing it and it'll blow it up and out of the way. So it's actually plastic that's just gotten really stringy. And yeah, I know there's no audio when I go to the main screen of the 3D printer itself. So that's what you're seeing right now is the nozzle. You can see, I mean, you can really see it if you kind of get in there and look at it. You can see the plastic come out of it and just kind of goop out. And it's really kind of satisfying to watch it draw those back and forth. That was a good view there. You can see it really just blowing down all that plastic. So looks like it's getting ready to make the last layer of this support. So the structure that you're seeing under there right now is actually support structure, because like I said, this is a car frame, a body frame for an RC car. So all these long lines you see it printing right there are actually going to break away out of this, but it needs that support so that it can print that long flat top. Because if you don't, I mean, it's just like anything, when you get that plastic still hot, it's just going to droop. So those supports there to help it make it hold its shape. So when this is done, we'll actually pull this off the bed and those will all break out of it. So unfortunately it is waste, but it's the only way to do that with high quality. It's pretty neat. Do we have any other questions out there in the feed? Anybody post your questions in the chat? Let us know what you got, what you're thinking of, so we can answer your questions. I know a lot of people aren't familiar with this technology, and I'm trying to get more people excited about it and involved in it, because it is my nerdy opinion, you know, and I like it when people talk nerdy to me, is that this is really a revolutionizing technology, because it allows us, especially people like me who are kind of creators, to prototype fast. I don't have to go out and, again, like I said, buy these standard boxes and hope things fit in there, or you know, or this is the smallest box they got, but I only need half of this thickness, so now I've got this oversized box for something, and I'd rather have, you know, something more compact that fits my needs, or it could be the opposite. You need a bigger box, but they don't make one that fits the dimensions you need. Well, make your own box. That's the greatest part about this. So if you guys have questions, put them in those comments. If you haven't subscribed to our channel, do that while we're talking about it. We sure could use your subscription. When we get to 100 likes or 100 subscribes on this page, we're actually going to give away some of our technology. We'll be giving away some of these. So make sure you're subscribed to our channel, because as soon as we hit 100 subscriptions, we are going to start giving away some stuff, and we're also going to start bringing some of our YouTube viewers on events with us. So if you want to be able to go on a ghost adventure with us and go investigate, you have to be a subscriber. And so that is the only way to come on investigations with us. You got to be a subscriber, and you got to follow us like that. And we are going to start pulling people as we hit our sub markers to go on some crazy trips with us. In fact, crazy as in I'm a pilot, and you're going to hop in the airplane with me, and we're going to go fly somewhere and do an investigation. That's how fun it's going to be. So make sure you hit that subscribe button. We really need you to subscribe so that we can continue to do this and continue to do what we love. We're all creators out there in some form, so please help us out. I'm going to switch back over, and again, I know there's no audio on this view, but let's just take a tighter look in. So you saw that big long jump it did there. That's where we get some of that spider webbing looking stuff there. So that's what causes that, is that little leakage that comes out as it's doing that huge jump. It's hard to keep it in there. You know, it's like when you use a hot glue gun and you've squirted it out and you stop for a second and it makes that little string. That's the same kind of thing. It's hard to completely get rid of that, but you know, doing a pretty good job here. We're not getting much of that spider webbing. We're getting good retraction back of the filament as it does the Z-hop. That's what that calls. It's a Z-hop. So just kind of watching that nozzle print that out there. You guys are online. Please let me know if you have any more questions. Just so you know, my printer is an Ender 6, which is a top-down printer, so it doesn't print from the bottom and basically like move up as it prints. Mine starts at the top, and the bed moves down as it prints, so it prints a little faster. The quality on this is phenomenal. I think for bang for your buck, this is one heck of a printer to have. Cruelty has a ton of different printers. This is not a resin. This is an additive. So this is not a resin printer. This is a filament printer. There's a big difference. Resin printing takes a lot more after. You got to do some curing and stuff like that. We can talk about that some other time. We don't use the resin printing. It just doesn't work for us. For what we use it for, this was the best way. Like I said, we do prototyping. So if you're curious on how to do this, again, you got to hop over to Fusion 360. And Fusion 360 is where we do all of our design work. There's a whole bunch of different ways to do this. So that's just kind of the gist of it. And again, we'll get into Fusion 360 in a future episode. There's a lot to cover there. In fact, we could do an entire series of nothing but Fusion 360s. And really, if you want the best tutorials on Fusion 360, just go to Autodesk. They have everything. In fact, I go there often to learn myself because I'm still learning Fusion 360 because it is so feature-packed. It does circuit board design. It does all your parts layouts. It does so much stuff. It even does the stuff that you would do if you were going to use a CNC machine and do milling. So you can do all your milling from it as well. So super, super versatile. But again, we're going to talk about that some other time. Here is a side view of the 3D printer as it's going. Mind the mess there. You can see my electronic little bin there and my helping hands. But that is the 3D printer back there with the blue and black. You can see the top nozzle there going a little bit as it's printing. That's what we're looking at. That is my 3D printer. It's an Ender 6. It is enclosed. It has the topper on it. And for that, it's just helping keep the temperature in there a little more regulated. So you're not getting cold drafts that come in and maybe cool off a section of your part faster and causes problems. I've noticed that once I put the topper on mine, it really prints flawlessly. Like I don't have any issue whatsoever. It's really kind of dialed in now. I've only had this printer, I want to say since November. I'll have to go back and look. There is a setup video on our channel if you'd like to see the setup, because I know some people were like, how hard are these things put together? It looks like it could be a pain in the butt. It really wasn't. I think it took me less than an hour to put it together, and I got interrupted a few times. But I do have a video of me putting mine together. It's a time lapse of me putting it together. There really wasn't a lot to put together. It came with the bottom completely intact. The arms I had to put together, but then the bed mechanism and railings were already put together, and I just had to put the wires together. I mean, there wasn't a lot to put together, and I can only imagine how much less of the printer. You can see I've got plexiglass, Lexan glass, all around mine, and other models don't have that kind of stuff. Now there are some other fully enclosed 3D. Other models don't have that kind of stuff. Now there are some other fully enclosed 3D printers, but you know, if that wasn't on my printer, I probably would have been done in 15 minutes or so. It really was nothing to set this up. It took more time to get it leveled, and there's a whole process you go through on leveling the bed to get that first set going. Then you run your first print. I think I had my first test print running within an hour, and it printed within an hour and a half, and that was my Rabbit. So that was my first print off this machine with literally nothing extra. I mean, that came out super duper smooth. The layers are all even, and this is before I even tuned it in even harder. So once you really start getting the hang of it and tuning it in, like I can see some flaws that I can already tell my printer now won't print this like that anymore. So it didn't take much to get there. So as far as fiddling with it and you know, messing around with it, I really haven't put in a ton of time to do that. It was pretty plug and play. So got to give props to Creality on the Ender 6. It's a workhorse, man. It really is, and that's great. Let's jump back over to just the big screen of the 3D printer, and we can watch that for a second as it's, you know, putting down some more layers here. And you can just kind of watch. You can see that print nozzle there just oozing it out. And it's really cool to watch that, especially when it takes that left turn and it starts going across the screen again. You can see how the plastic is actually coming out of that nozzle and how it just sets it down there. And it makes a nice, even, flowed line of plastic there as it comes back and forth. You can see it right there coming right out of the end of that nozzle. So it's really, really cool. And again, what you're seeing right now, these long lines of stuff that it's printing, that's actually going to break away from this model. This is that's actually going to break away from this model. This is a car frame for actually RC car. So it's the outside shell of a car. A car frame almost done a RC car. So it's the outside shell of the car. Pretty much printed now. So it's getting ready. It's almost done the end part to go to the. You can see the hood's pretty much the top of the car. So it's getting ready. It's building up right now. The end part to go to the very top, to the top of the car. It's pretty cool. You know how it does that, because you know if it's hot plastic, it'll sag. It's pretty cool. Stuff that's all taken care of in your how design it does software. So if you get your object design, and you go to slice it, that's taken care of in your design software. So pattern that the nozzle is going to go. Design, you can tell it to slice it. You don't actually have to build the layers, the pattern that the nozzle is going to go. You just set the parameters. You can tell it to build supports. You don't actually have to build that. And so it'll build those up. You just set the parameters of when it's going to the side mirrors that are on it, and so it'll build those up. A build-up plate to cover up the hood, and then the side mirrors that are on it. Tail end a little bit, and it's got a build-up plate to cover up the hood, and so that's what it's tail end a little bit, and that's what it's doing right now is it's building all that up, and it puts it down real fast because it knows it's going to break away, so it doesn't care. And that's what it's doing. The layers are super awesome. It puts it down real fast because it knows it's going to break away, so it doesn't care if the layers are super awesome. It's just taking care of that, so you get easy removal when it gets done. So. But it is kind of mesmerizing. It's really satisfying to kind of watch that thing in, you know, like. But it is kind of mesmerizing. Perfect little swipes to kind of watch that thing in the shapes. It's kind of like those artist color. It's almost a little soothing little swipes back and forth. Fill in the shapes. It's kind of like that, you know. So watch out. It's almost a little soothing to watch hypnotized by the 3D printer. Kind of hypnotizes you. If you're out there watching, just let us know if you have any other questions. Hypnotized by the 3D printer. If you're out there watching, just let us know if you have any other questions. Like I said, we use it to build our equipment. This is something I've been working on here for just a little bit. In fact, I can show everybody again to build our equipment. This is something I've been working on here for just a little bit. The prototype. In fact, I can show everybody again what this was. So the first prototype was this one right here. And so what's really great is you learn from your mistakes. So I printed this with these posts, so you can kind of see what's really great is you learn from your mistakes. So I printed this. Those posts went all the way flush with this, so that when you put these two parts together, Down
those
here,
posts
you can
went
see
all
the
the way
screws.
flush with this,
You can
so
screw
that
those two parts
when you
together.
put these
I
two
made
parts
those posts
together,
threaded internally.
down here you can
which
see
is
the
a feature
screws.
that the 3D printer
You can
can
screw
do.
those
They
two
can
parts
actually
together.
print
I made
threading,
those
so you don't
posts
have to
threaded
have
internally,
any inserts,
which
or
is a
anything
feature
like
that the 3D
But
printer can do. It
one
can
of the
actually
things
print
that
threading,
happened
so you don't have to
was
have
any inserts or anything like that.
when you
But
screwed it onto the top.
one of the things that
it
happened
over-torqued.
was
broke them. When you screwed it onto the top,
the joys,
it
right?
over-torqued. So we learned from that mistake. So
Broke
what
'em.
did we do? Well, we took from that
the
mistake
joys,
and
right?
we built. So we
This
learned from
part
that
here.
mistake. So
So
now
now
what
that
did we
you can
do?
see,
Well, we
it is
took from
actually
that
all
mistake and we
part.
built this part
Let me figure
here.
out how to get
So
it
now
in
that
there.
you can see,
It
it
is
is
all part of
actually
the outside
all
edge of the
part.
case now.
So it goes all the way
Let me
down,
figure
it
out
goes
how to
all
get
the
it
way
in
up. And now
It is
instead
all
of
part
being
of the
a
outside
threaded
edge of the
hole,
case now.
we actually put
So
a
it goes
hole
all the way
to
down,
where
it
we
goes
can
all the
put
way up.
in
And
one
now
of our
instead of
brass
being a
fittings
threaded
that is
hole,
threaded
we actually
itself.
put a hole
So the
to
brass
where we
fitting
can put in
one of our brass fittings that is threaded itself. So the brass fitting there we go. I think I figured it out. Thanks for telling me that, babe. The brass fitting, let's take it back so you can see there. The brass fitting fits in there. I got your message. The brass fitting fits in that hole now, and you just get the brass hot and press it in. That way it takes all the torque off of the frame of itself, and you don't have that problem anymore. Plus, since we made it part of the outside, I mean, you can hear that. It's strong. That's what I love about it. It's just as strong as anything you can buy from the store, but you get to customize it. And by say customize it, and you can see here, we put our names in it. We put the product in it. We've cut holes through it for some lighting. Pre-cut the switch on it with on and off above it. So it's really great that that's there. It makes life so easy. And I really love the ability, just the freedom it brings to kind of test and work with your own gear. So does anybody have any questions? What's going on, and you can see the printer printing, laying down that plastic. That's a great shot right there, seeing it come out of the end of the nozzle. Look at that. Just kind of lets you really see it kind of come out and building those layers up. And so it's just a great tool for those of you that like to build your own gear, or you like to tinker, prototype. I'm too inquisitive to just sit by and do nothing. So I love doing this. I hope you enjoy seeing this and understanding how it works a little bit more. And I hope that you think about doing it yourself. You know, if you're not ready to do 3D printing, well, let's do a couple more episodes of our Tech Tuesday, and we'll get you to the point where I think you're going to be really excited to start prototyping. Or if not, you know, message us. Let us help prototype some of the ideas that you might have. If you've got an idea for gear, come to us. We'll help you design it. We'll print it off and help prototype it with you. If you don't want to do it yourself, you know, if you've got the idea but you don't want to go through the expense or the learning curve to do this part, contact us. We'll help you. That's what we like to do. So I just had a question come in. It said, what am I using to design the items that we're printing? So I use Fusion 360, and I'll switch over to Fusion 360 real quick. So there's Fusion 360. It is really, really easy to use. And so basically you start off with just a sketch. So let me dump some stuff here. So you just start off with a sketch of what you want, and you can kind of just build from there and just kind of play around with it. You use a pair of calipers and just kind of figure out your distances and measure things, so you know the size of stuff, and you just type it in. You don't have to be an artist to make this work. I mean, it literally does everything for you. And like I said, we'll do some episodes with 360 and do actual design work in it. But if you want to get started right away, Autodesk, which makes, you know, AutoCAD, or they used to make AutoCAD. I don't think they call it AutoCAD anymore.
you can go over to their YouTube page, and they've got tutorials left and right on this stuff. So feel free to get started learning. It's not really hard. It's just too much fun to learn it. So sitting there watching, you can see the 3D printer up at the top. You can see the light. If you see that white bar going across, that looks like that's actually the edge of the hotbed, which that bed is actually heated so the plastic sticks to it, and it kind of manages your temperatures in there. That comes down, so we got a lot of room that we can build from. That comes down, so we got a lot of room that we can build. We're getting close to finishing this print. It's been going for about 21 hours. Nonetheless, we're getting close, and it's almost done to finishing this print. It's been going for about Phil's going to be happy about that. And it's almost done. Do we have any other questions out there? I know Phil's going to be happy about that. Is the software specific to the printer, or can we have any other questions out there? 3D printer. It can be used with any 3D printer. Is the software specific to the printer, or can it be used with any 3D printer? It can be used with any 3D printer. In fact, Fusion 3D not only does 3D printing, but it can kind of do. But it does slicing. It also does circuit board designing software, which product layout. It can kind of it also does circuit board designing, machining. So if you wanted to make something out of metal, it'll actually do the machine movements to do CNC machining. So if you wanted to make something out of metal, so we got another question. It'll actually do machine movements to do CNC machining out there. Quality. So we got another question. Why do we choose Fusion 360 over other design programs out there? It's also pretty user friendly. There's a lot of 360. I believe Blender does it on quality. It's also there's quite a few other ones, but there's a lot of other stuff. I grew up, I believe Blender does it. There's quite a few other ones. I really I grew up using AutoCAD. This one kind of just came natural for me to go to an Autodesk product. Made AutoCAD, so it was really this one kind of just came natural for me to go to an Autodesk product. Audio made AutoCAD, so it was really good. There we go. Got to work out the bugs, don't we? Oh, goodness. All right. I just love watching this thing print. It's so satisfying to see it feel like what it's doing right now, filling in those gaps like someone painting. It's just kind of like, that's pretty neat. In fact, let's go over to the main camera real quick so we can watch that. So the first question we got asked, someone said the audio was a little iffy. Can you repeat that? So we are using Autodesk Fusion 360 to do our printing. We chose that software because one, there's a free version, and what we're doing with it is just prototyping. So we're using the free version to just kind of do some prototyping. Once we get into operations, we'll upgrade to the commercial, and so we'll go from there. But I'm just kind of feeling it out and getting used to it. There are other software out there like Blender does it, but I grew up in AutoCAD, so this is what I chose to do. No, you don't have to use specific software with each 3D printer. The Fusion works with every one of them because it saves in a file type, and the file type is what's important, because you bring the file type into your slicer and it looks at it and it kind of takes it from there on basically making the path of how that 3D print nozzle is going to go around this. And then that file gets saved out and actually goes over to the 3D printer. There's a lot of tweaking you can do with that on how fast it goes, how hot it gets. You can change the temperatures up and down. And there's a lot of tweaking that you can do to really make everything work really great. So, kind of as we watch this print finish up here, just go out to the board here just one more time to see if we got any final questions. Again, this is a great technology if you want to get into it. Like I said, if you've got ideas on gear but you don't want to, go through the expense of building your own 3D printer, buying a 3D printer, or learning the learning curve to using the software, contact us. We'd love to work with you on prototyping some stuff for you. We're happy to work with anybody. That's what we're here for. We look at the community as colleagues, not competitors. So by all means, if you have ideas, get with us. We'd love to help make those ideas come to life for you. There's nothing more satisfying,
to get your final product in hand and be like, man, this is, I thought of that and I made that. I made that. That's a really satisfying feeling. So I want to thank everybody for joining in, unless I see any other questions pop up in the chat. While I got your attention, please go ahead and hit that subscribe button. We are trying to get to 100 subscribers, and when we do, we're going to start giving away gear. When we hit 1,000 subscribers, we're going to start bringing people on investigations with us, and it's going to be fun for those investigations because, like I said, I'm a pilot, and we'll hop in the airplane and we'll go fly somewhere for an investigation. Who knows? Old Park's calling my name again. We love going out to Old Park. So with that said, I don't see any new questions coming up. I want to thank everybody for joining us on the very first episode of Tuesday Tech Talk. We'll be back here again Friday. I believe it's March 4th. It's the first Tuesday in March. We'll see you then. Don't forget, coming up Friday, we have Friday Night Frights. We're going to be talking to the owners of the Bowers Mansion out in Palestine, Texas, because we're getting ready to do an investigation there in March. So we'll be talking with them. We're also going to have a live investigation coming to you from Haunted Hill Manor in Gainesville in 2 weeks, February 19th. We'll be broadcasting from there, so we can't wait to see you on that one. We got a lot coming up. If you haven't seen our event page, please make sure you go right there to Facebook, Texas Ghost Geeks on Facebook. Follow us. You really want to follow us because that's where we put all of our event notifications on. Our live broadcast notifications are in there. And then, if you really want to do some other fun stuff, follow us on Texas Ghost Geeks. We post a lot of stuff from all of our wacky adventures that we do. And then, of course, right here at YouTube, subscribe to us on our YouTube channel. We're trying to get those subscriptions up to 100 so we can start giving away gear. We've got a stockpile of stuff we've been building to give away, but we need to get to 100 subscriptions first before we start giving away stuff. So please make sure you hit that button and follow us. It'll also help you keep on top of whenever we go live here. You'll get that notification, and you don't want to miss out. So again, thank you guys for being here for the first episode of Tuesday Tech Talk. We'll see you next week. Have fun. We're going to end out on our 3D printer cam. You guys have a great time. Until next time, I'm Chad with the Ghost Geeks.